Hello everyone, my name is Adam Korbel. I belong to the Renesas Digital Products Marketing Division. I'm happy to share with you today Renesas understanding about E architecture evolution and details about our ARCA S4 based reference design and proof of concept use case. Coming to today's agenda. So first item is to share with you our understanding for the automotive market trends and its EE architecture changes. Then I'd like to share with you the overview about the Renesas product portfolio, including the digital parts and analog parts later on. Then to share with you our understanding about the winning combo. It's a big buzzword on Renesas side. Then at the end, we will show you a demo video of our ARCA S4 based reference design, and we will close the session with a summary. So for motivation, why we are doing new product developments. So basically we follow the automotive mega trends and changes, where we expect 2-digit percentage market growth over the next years. So the first one is the electrification of vehicles. This is the transformation from traditional combustion motor based vehicle to the electrical vehicle basically. Then the second soil is the automated driving. So here we see the camera and the radar-based systems, which protect the driver from accidents and allow more relaxing driving. And for the next soil, for the connected one, the highlighted one, there we will have the focus today. This basically allows the operation of a car server inside a car, the connection to cloud services. This is basically the base of the software-defined vehicle. In this webinar today, we focus on our solution for this part, which will be shown on the next slides. But first, let's share with you our understanding how the EE architecture inside the car is changing. So basically on the left side, you see today's situation on traditional car maker side. So you have a high number of ECUs inside the car with increasing amount of data. And these ECUs come from many different hardware and software suppliers. Issues are, for example, secure communication inside the car. CAN-FD is the most widespread communication standard. And in average, an average car has 70 ECUs inside, a premium car up to 120. And basically that's a big burden for the traditional car maker. They want to reduce the number of ECUs and want to go for more centralization. You see that all in the middle. Basically, what we mean with tomorrow is a car maker SOP between today and 24. So it's more centralized. So you see already here a vehicle car server module connected to the ADAS and IVI cockpit modules, and also connected to cloud services. Gigabit Ethernet is already introduced in that kind of architecture. Over-the-air update is one of the biggest targets. That's the reason why you have the cloud connection here. And of course, the bill of material needs to be reduced. So you have more features inside the in-vehicle car servers and in the ADAS and IVR domains, and less features in the domain ECUs, but there are still a lot of ECUs existing, basically carried over from older designs, from legacy designs. And exactly for that kind of architecture, we will show you later on the demo and video, and for that kind of architecture we have built this reference design we will show you later on. And what brings the future, you see it on the right hand. It's even more centralized, so basically everything goes inside the vehicle server or central computer. Ideally, it's only one ECU, and ideally maybe only 4 zone ECUs outside, without so many suppliers as compared with today's situation. Also there, the amount of data handling will increase rapidly, and the real-time performance requirement will also increase. So here you need to implement new communication standards like the multi-gigabit Ethernet as backbone. This will be required for sure, or new communication standards for automotive like the CAN XL or 10 megabit T1S will be realized for that. All right. So how we are doing that with our digital products? Most of you know us very well, from the microcontroller area. So here you see our roadmap. So for the low-end application, we have the RL78 16-bit micro series. It covers the actuator sensor application, and then the RH850 32-bit micro series, which is covering the body, chassis, powertrain applications. These two well-known MCUs basically cover all kinds of domain ECUs today. For the mid and high-end performance application like IVI or HMI cockpit, the connected, the ADAS, and autonomous domain. So we have our ARCA series, SoC. These are microprocessors in our portfolio. And on the following slides, we will concentrate again here on the connected gateway area. So for this area, we have developed a new device, the so-called ARCA S4 SoC. And that one is the first one with a monolithic integrated RH850 MCU on board. Okay, how looks the concept for that basically, and what is our strategy for that, and most important, which value it brings to customers. So basically, the amount of software complexity is increasing in new architectures. So software development becomes more important. The cost impact is huge, meanwhile, compared with the effort on hardware development. So the reusability, scalability, and portability of devices and its software becomes more important, because it will save a lot of time, effort, risk on customer side. So therefore, Renesas is contributing value to our customers by means of reusing the same IP of the RH850. When you look on the low end here on the microcontroller, by using the real-time CPU system and MCU feature set to the mid-end SoC, the ARCA S4, and followed by the reuse of the application part CPU-related system, to the high-end. And analog to the reuse of hardware IP, we reuse also software. A high grade of software reuse is possible by means of the usage of common software across the application. So also this brings a high value, especially to our cross-domain platform customers, who use our devices in different applications or segments, because it helps them to be more flexible and efficient in their development, because they can reuse simply software, across the application. All right. Coming to the connected gateway as such, or some people call it high performance computer or vehicle server. So what are the challenges here? So of course, the real-time computation capability and the MCU feature set, like for example the low power modes, need to be implemented also here to allow low power consumption. The gateway functionality, including gigabit Ethernet and high performance routing from one communication IP to the other, is a big issue. The integration of the latest security standards and HSM to ensure maximum protection against hacker attacks is very much important, especially with regard to the over-the-air software updates. Here the ARCA S4 acts for OTA orchestration, to allow customers the integration of their own application software via cloud services. So as you can see on this slide, we offer a complete Renesas chipset solution for the connected gateway. It's not only the SoC who integrates MCU functionality and gigabit Ethernet switch, but it's also the analog chip, the power management IC, and the timing IC. Okay, so details for that we will show you on the next slide. So with the ARCA S4 and the power management IC, we are capable up to functional safety level SLD. That's possible. Both parts were developed in parallel and basically tailored for an optimized system performance. But first, coming to the ARCA S4 and its product concept. So the ARCA S4 series is designed to meet the needs of the next generation communication gateway market with increased performance. You need fast startup and standby functions, as well as elemental new technologies in automotive, such as gigabit Ethernet and integrated security. That's one important point. You want to reduce the bill of material cost, and that's the reason why we have a higher monolithic integration level in the ARCA S4. This was realized with an integrated MCU and feature set. Moreover, we have integrated a 3-port gigabit Ethernet. on the chip, and also an HSM and fully integrated hardware security module. So by means of these measures, it was possible to increase the safety level capabilities up to ASIL-D. That was not possible before at the old ARCA Generation 3 series. Then other feature sets, so freedom from interference support is also a key feature, and we offer support for that by means of region ID and SPID access protection. Yeah, and of course with the usage of hypervisor software. So basically for this concept, we have collected experience from the field, from running projects. Yeah, you have read it maybe in the press releases over the last years, where we have one project based on discrete designs with ARCA Generation 3, and learned from that we have done this higher integration. Yeah, basically we have taken the best DNA from ARCA Generation 3 and from RH850U2X on this ARCA S4. So for the engineers of you, you will love the block diagram, of course. This shows you the entire feature set of the ARCA S4. The yellow or orange parts are the new features compared with the Generation 3. The -8 in the product name stands for 8 application cores you see in the CPU system. This is the device with the highest performance in our device lineup. Just to highlight here the new features. We have an enhanced application CPU system. This is capable up to 27 kDms application performance. And these core set can be switched by software to lockstep mode, and then it ensures the SLB compliance. Then we have a real-time CPU system with one ARM A52 core and two G4MH cores. This naming comes from the RH850 MCU series. They are hardwired in lockstep, and they are also on board. The real-time performance is in total 5.3 kDMIPS and always in SLD mode. As said, the monolithic integration level is increased. It's covering not only the SoC features you know from the Generation 3, but it also covers the MCU feature set, core set, a lot of connectivity known from the MCU, and also the power management IP here, known as, for example, as deep standby control mode or cycling wake up control mode. Yeah, this power management IP is very smart because it can ensure passive cooling on customer side. So, moreover, it has a rich number of connectivity. Yeah, that's also new compared to Generation 3. For example, the 4 lanes PCIe 4.0. So, or the 3-port gigabit Ethernet switch integrated. Here it ensures 3 times 2.5 gigabit Ethernet MAC for Ethernet AVB and TSN, and a high number of legacy IF, such as 16 CAN-FD or 16 LIN, 8 cent, 1 flex ray, and moreover the possibility to connect several external memories by different memory IFs. Yeah, as you can see on the slide, like the UFS or EMC 5.01. All right, so coming to the next agenda item, the winning combo. So first of all, what is a winning combo? So this is a nickname, our Renesas nickname, to describe a complete Renesas chipset solution, a so-called winning combination. It's covering the analog and digital ICs taken from our company merger and acquisition activities over the last years. And these new technologies and know-how allow a better and optimized coverage of our customer requirements. This holds here in this example from energy saving to computation performance, improvement within different automotive applications and market segments, like shown on this slide. So a very much holistic approach. Okay, so with regard to the connected product portfolio, so basically this is a winning combo. It's broadened with the analog part expertise and with the products as shown on this slide. So so the highlighted part here in yellow is the winning combo, which we offer together with our ARCA S4. So it's covering also the power management IC and the timing IC. Yeah, and of course, in the middle, you see the digital part, the MCU or the SoC in this case. This is basically the brain of the chipset. Yeah, so the total chipset allows us to offer to you an optimized system performance. That's the reason why we are doing that. Okay, so coming to details and with regard to the demo and the reference design, we will show you later on. So evaluation boards available for the ARCA S4. So in our demo, we will use this highlighted part, the evaluation board. This is the so-called spider board. On this board, we are using this winning combo chipset already for reference. It covers the ARCA S4, and also here mentioned are the part names for the power management IC and for the timing IC. Yeah, of course, other evaluation boards are also available, like the starter kit or the vehicle computer, but they are not the scope of today's webinar. Okay, so coming to the analog parts, like the power management IC, as said, it was developed in parallel to the ARCA S4 SoC. So it's a really tailored solution. And the PMIC solution consists of two parts: the high voltage buck regulator and the low voltage power management IC, who takes care for the power supply monitoring and for the control without using an external MCU. So here also the bill of material can be reduced compared with today's designs, and the customers can save cost. Yeah, coming to some key features of the RAA 271041 and the 1005 or 6 power management IC. Both were developed per ISO 26262 standard and are capable up to SLD. Some key features, for example, the programmability enables easy adaptation to support the ARCA S4 and other future ARCA SoCs. Advanced power control is implemented to support extremely low power operation for always on, for cycling run mode, and for suspend to run modes. But the devices offer also other features which should be covered in a separate analog webinar. Okay, coming next to the timing IC, the next analog part used with the ARCA S4. So highlighted here are the parts which I use with the ARCA S4. The benefits on using our timing IC on the ARCA system platform are basically they are from proven designs, which are operating with the ARCA platforms. Also here, bill of material reduction is possible, because it's only one single timing IC. And it's programmable, for several different clocks and frequencies. And it can reduce the number of conventional oscillators, crystal oscillators. So also here you can ensure a development cost reduction, because of minimized design effort. All right, so coming to the reference design, we will show you later on the video for that, but some brief introduction. So basically here our engineering team has built up a reference design, which will be shown in the demo later. The target of this design is to allow our customers an easy and quick start in their development or in their own proof of concept or even automotive network evaluation, whatever they want to benchmark. So our reference design shows the communication gateway functionality of the ARCA S4 by means of routing and converting several application data. Here we do it with USB camera data coming from driver monitoring system, DMS, and from driver video recorder, and from basically body ECU via CAN bus data. Another ARCA M3 board is driving the dashboard display basically, and it's connected to a servo motor to demonstrate real-time steering operation. So the hardware reference design comes together with a proven reference software package. You see here on the right-hand side. It contains the real-time domain software such as FreeRTOS instead of using a classic AutoSAR, and routing software. And for the application system, it contains the Linux BSP, routing software, and so DMS and DVR related application software. So please enjoy the demo video now.
In this POC, the ARCA S4 performs video application processing as well as routing processing. The three applications are DVR, DMS, and body control. The ARCA S4 CPU performs real-time encoding for DVR and face detection for DMS on the video input from the camera. In addition, CAN signals for motor control and vehicle condition data from the CAN analyzer are input to ARCA S4 via RH850. Please see the actual demo in action. First, let's start with the DVR. The recorded video is saved to eMMC memory along with the real-time display. The saved recordings can be listed and any recording can be played back. The second is DMS. When the driver is seated, the system first detects the driver's face. If it determines that the driver is talking on a cell phone, falling asleep, looking aside, or smoking, an alert is displayed. The third is body control. Vehicle condition data and motor control data are input to ARCA S4 via RH850 as CAN signals. Vehicle condition data is stored in eMMC memory, and motor control data is routed to motor control. Finally, let's review the benefit of this solution. Provides evaluation-proven reference software environment with SoCs and MCU evaluation boards combined. Contributes to reduction of customers' initial examination period and cost, and enables feasibility study of system rationalization. Enables evaluation under high data rate conditions for communication using video data input, output via Gigabit Ethernet, PCIe. R-Car S4 can run not only the basic communication gateway functions, but also the video processing application, DVR and DMS. System benefits of this POC reference environment to ease the development burdens of the customer.
All right, so hope you have got the audio and video properly. So in summary, so what we have shown today in this webinar is that Renesas is able to support the new E architecture market trends with our new chipset solutions. Because we are adding new features which are required by our customers. Like for example, the enhanced functional safety level up to SLD, or Gigabit Ethernet and integrated security modules. We offer a scalable product lineup. So for the communication gateway application, so they are ranging from the very low end, basically a classic gateway device can be still realized by means of an MCU-based, an RH850 U2X solution, and up to the high end, which can be realized with the R-Car S4 SoC. With our SoC, we realize an increased monolithic integration level, which reduces the build of material on customer side. In our approach with the R-Car S4, we have integrated the MCU feature set and Gigabit Ethernet switch, for example, and by means of reusing the IP from the Gen 3 R-Car series and also from the RH850 MCU series, we estimate great software reuse. So today we estimate it as over 80%. This brings cost benefit to our legacy customers. We don't offer only the digital parts, but we offer the entire chipset, the winning combo that's shown already on our evaluation boards. And this tailored chipset we use also for the reference designs. We are doing that because it offers an outstanding system performance, especially with regard to the computing performance to power consumption ratio. As we have shown at the end, we have available reference designs. One of them we have shown today. It's dedicated to the gateway, DVR, DMS, and body control application. This one is available based on standard evaluation boards from our side, and we offer it to our customers together with reference software environment to allow them a quick and easy start in their development or proof of concept phase. So all these approaches enables our customers to have a quicker, better time to market for their projects. So at the end, I'd like to encourage you to get more information about our products and services via our webpage. You will get also the link to this site. And please also contact your local Renesas sales agent to get more information and product documentation. So thank you for your attention today, and bye.